Okay, we're going to look at sketching in polar form now. So they want us to see what curve is represented by the polar equation r equals 2. We're going to do this on the calculator. So what you're going to do is pull up your calculator. You're going to go to mode. And then we want to be two things. We want to be in radian mode here. And then if you go down one, we're in function mode. Here's parametric we've looked at. If you go over one more, that's polar form. So we're going to go into polar form here. All right, so now if you go back and you go to your y equals to graph, you should see that it says r equals. So here we're going to put in what is r equals 2. Just so we're graphing on the same one here, let's do this one in number 4, the decimal one. And if you graph this out, you can see that you get a circle. So the graph of this one is going to be a circle, and if you look closer at it, it's a circle that has a radius of 2. And so the graph of this one, you get a circle. So it's a circle with radius 2 because the pole here, that's our pole, has a length of 2 everywhere. So that almost acts like our radius here of this circle. It has a radius of 2 everywhere, so you get a circle. Let's look at another one. Sketch the graph of the polar curve theta equals 1. Well, if you go on your calculator and we try graphing this one, you're going to run out of luck because you only can enter in r equals equations for polar form. So what does that mean if you have something like theta equals 1? Well, that means this is 1 radian. 1 radian here. What is the graph of 1 radian? Well, that would just be the graph of anything that has a radian of 1 along that line. So if you measure 1 radian, which if you want to know what 1 radian looks like, do 1 times our conversion here of 180 over pi, and it would tell you, and it's going to be around like 50 some degrees here if you go on your calculator. 180 divided by pi here. So one radian is about 57.3 degrees. So anything along that line of 1 radian then would be part of this graph. So this would go indefinitely in both directions. So if it's only a theta, you're going to get a straight line in polar form. All right, the next one, they want us to sketch the curve with the polar equation r equals 2 cosine theta. So let's, again, graph this one out. We can go on our calculators here and do this. So we're going to go to our y equals here. We're going to type in 2 cosine theta, and this is why you need to be in radian mode here. Now notice if you hit our variable button, it gives it to you as a theta or angle, not an x when you're in polar form. Hit graph, and it looks like we get a circle there that again has a radius of 2, but it's centered at the point 1, 0. Here's another look at what this one looks like here. So what you would see here is if you graph that one out, you would also get these points on the curve here. So for example, if you enter 0 in here, what's cosine 0? 1. 1 times 2 would be 2, meaning that would be the first point on this graph. So over here, it would kind of start here. And then if you did the next point of pi over 6, you'd get square root 3. And so this one is moving in this direction up here. You'd get that, and it keeps moving in this counterclockwise position here and makes this circle. You can pull up on your calculator the table, and it'll give you different values here. Now, my calculator is going by ones, which isn't great for this, but these would all be points still on that circle. You can change your table settings here if you'd want to do that. So if you want a table to start at 0 and maybe go up by, let's say pi over 6, you would get some of these values. You wouldn't get all of them. But if you go over here, there's some of those values there, and you can see 1.7 is the same as a square root of 3 there, so you can see you do get some of these same values we had in this one. But you'd get those by plugging those numbers in and figuring it out. Okay, the second part of this one wants us to find the Cartesian equation for this curve. This one's a little trickier. Normally, if we're going to do this, we use our conversion here of x equals our cosine theta to find the x one, and we use y equals our sine theta to find the y value. But our equation here is r equals 2 cosine theta. So if we would just put that in, we get 2 cosine theta times another cosine theta. That's not really going to get us where we want to go with our Cartesian equation. So in this one, instead, what we're going to do is we're going to kind of manipulate this equation up here. If we were to take this, and if we were to divide by 2, this would also tell us that cosine theta would be equal to r over 2. So what we're going to do now is take that result, what cosine equals, and we're going to plug it in place here of cosine, because that's what cosine's the same as. So now this turns into r times r over 2, or another way of writing that is r squared over 2. Then what we're going to use is kind of that other conversion that we have, that x squared plus y squared equals r squared, and we're going to substitute in our result here, but we're not going to do it for x. What we're at, because Cartesian coordinate, we want x and y. So what we're going to do is times by 2, and if we do that, we see that r squared is equal to 2x. So we're going to take this result now, that r squared is equal to 2x, and we're going to plug that in place of r squared there. So our equation becomes x squared plus y squared equals 2x. So next thing we're going to do now is move this around a little bit. We're going to bring that 2x over to the same side as the other stuff. So now I'm going to write it as x squared minus 2x. I'm going to leave some space here, plus y squared equals 0. To see what this equation is, we're going to use completing the square here and figure out where the center is. So remember, to complete the square, when you do completing the square, you want to take half of this amount, half of negative 2, square that, and that's completing the square. So we get negative 1 squared, which would be positive 1. So we're going to add a positive 1 to both sides to complete that square. So now what this ends up being is x minus 1 times x minus 1. If we factored that, or another way of writing that is just x minus 1 squared plus y squared equals 1. And what that would be is that's a circle. That's the equation of a circle. And the center here would be the point 1, 0. And this is the radius squared. R squared would equal 1, and so r would be 1. So it's a circle centered at 1, 0 with a radius of 1, and that's exactly what we got when we graph this. Here's our point, 1, 0 right here. That's the center, and the radius you can see is 1. So that would be the Cartesian equation for that. All right, let's try some more here. Let's sketch the curve of 1 plus sine theta. Let's use our calculator again to help us out. So we're going to go back here to calculator. Let's type this one in. So 1 plus sine of theta. And we're going to hit graph. And there's the graph of this one. This is what's called a cardioid. That's the term given for this kind of shape right here, is a cardioid. I don't know where that term came from, but that's the term for this one. So where does this one start? Well, if you plug in 0, sine of 0 is 0, so the r would just be 1. So the starting point on this one, if we were to make a table here, sorry, switch this around, theta would be first. Theta is our input value, r is our output. So at 0, r would be equal to 1. So our starting point here is at 1, 0. If we were to do another point, say at like pi over 2, now if you did that one, r equals 1 plus sine of pi over 2. Sine of pi over 2 is 1, so you get r equals 1 plus 1, or r equals 2. And so here r would equal 2. So that would be this point right there. If you continue on and find more points at pi, if you put pi in here, sine pi is also 0, so there you get the point right there. If you were to do sine of 3 pi over 2, that ends up being negative 1, and so if you do that one, you get 1 plus negative 1, which is going to be 0, so that would be the point there. So that's why you see a point right here now at 0, and if you continue on at 2 pi, it's going to end up being the same thing as 0, and so we get this kind of shape right here that is referred to as a cardioid. So that's another example of a graph in polar. One more. Why don't you pause the video here and put this one in your calculator and see what you get. All right, if you put it in correctly, you should be getting kind of this clover leaf shape, which is kind of a fun little polar graph here. So again, if you put in 0 at 0, cosine of, or 2 times 0 is 0, cosine 0 is 1. So it's starting out right here. And then it goes kind of in this direction where we're going to travel this way. Then it goes down here, comes back up, and it kind of keeps going in this direction, making this 4-leaf clover shape. And eventually you'll come back here, and then right here at 2 pi, you're right back there. For now, we're just going to look at the graph of that. Later, we're going to get into how do you find like the area of that. And then it does make a little bit difference of how you travel when we start looking at how you find the area of something like that. But that's an introduction to sketching and graphing in polar form.